software. This is a winter blue ocean update, so we look at different predictions for when we will have a blue ocean, no sea ice at all in the Arctic, even in winter. So this is the annual average volume of sea ice in the Arctic based on the Pyomas dataset. And some of you may know that Pyomas has reported record low volume for the date for all of March, and will likely do the same for all of April. And that means that you have a downgoing graph for the annual volume, because we are lower than we were last year for every day. And you can see we have been going below 13,000 cubic kilometers during April, and now the latest line is 12.9 thousand cubic kilometers. So at this rate per month, we will lose all the sea ice volume for the whole year by August 2023. And then you may interject that this is only based on the last month, which is too short a period for making such a long-term prediction, and we'll get back to that in a couple of slides. So you have August 2023 here, and the rest of this light cloud is the predictions from similar runs of the same app. And the year 2023 is, you can see here, the second most likely after 2021. Just come out as the all year ice-free year most often thus far. And both of these, of course, belong to the 2020s decade, which is the most likely decade we will lose all sea ice, even in winter. And the second most likely decade for that is the 2030s. So you can make what you want of that. These are all based on short-term loss trends for sea ice. Then we proceed to this slide, and here you can see we have longer trends, longer than a month. We have everything from a half-year volume loss trend to 3-year volume loss trends. This has nothing to do with 3-year-old ice or 2-year-old ice or anything. This is just the how much ice volume we've lost over the past 3 years, 2 years, 1 year, and a half year. So what you see down here is you have the month of this year, January, February, March, April. We'll get to May. And the reason you have these months is that for instance, the 3-year loss trend is different at the end of April than it was at the start of January, because the start of the 3-year period is now April, and the end of it is April 2017. While in January, of course, the start of the last 3 years was January. So the new thing here is that 2029 or the 3-year trend has come down into this 2020s decade plot. So from about mid-April, you can see the 3-year trend is also inside this plot, and it's suggesting 2029 as the year we will lose all ice all year. But the main field here is 24 to 25, which is suggested by the 2-year trend and the 1-year trend and the half-year trend. So this is sort of an outlier, and this is the perhaps more likely prediction. And all of these are based on a simple linear projection of the loss trends that we already have. And how likely is a linear decline of the volume? You be the judge. Maybe it will be slower than linear, and maybe it will be faster in an accelerated collapse as we pass more and more tipping points. More and more feedbacks come into play, and the feedbacks get stronger. I don't know. So, next slide. So we see on the volume side here, we can see August 23, which was suggested by the monthly decline trend, is here, and the 24 to 25 is about here, and the 3-year trend pointing to 2029, that's over here. So somewhere here is where we expect to go all year ice free if we have linear trends following the month, half year, 2-year, 3-year volume decline trends. And so all of those are actually before this green trend line, which goes down to 2035. And you can also see we are closing into, we are soon going below the green trend line. And yeah, we don't know whether it will be surfacing above the trend line again, but probably will once or twice more. But it could also go into a much faster and accelerated collapse based on the very real feedback mechanisms in the Arctic, in the climate system. So interestingly, you have on the NSIDC extent graph on the right here, which is much more flat and which only goes to 0 in about 200 years, the year 2222, about that. It's actually starting to bottom out, or it's actually started to go a bit up, and that's mainly to do with the way the Americans are measuring their sea ice extent. It's different from the JAXA, the Japanese extent, which is lower. So by measuring it the way the Americans do, they may be able to actually start going up, and maybe even going higher than the green trend. So that would be interesting to follow. You know, if you were actually to have a very, very rapid collapse like we've started on here, and going down somewhere in the first half of the 2020s for the volume, then obviously the extent has to go down to 0 somewhere before the end of this plot too, because you can't have 0 volume ice and still have millions of square kilometers of surface ice. That's not possible. Okay, final slide. So we're now at the situation after 4 months of the year where the year-to-date average for sea ice volume, extent, and area are all the lowest ever in the satellite era since 1979. So that's the average for the 1st of January to end of April. So you could already say that 2017 is a record low year for sea ice, at least so far. And prospects for keeping the sea ice or keeping more sea ice than previous years in 2017 are pretty bad. You know, we're already lowest ever. And if you want to know more about why that is, you could check out Professor Paul Beckwith's latest YouTube videos, where he lists all the positive feedback mechanisms and how they all come into play when we lose more and more ice and we heat up the Arctic Ocean. And when it comes to how all of those dozens of positive feedback mechanisms work in concert together with each other, the jury is still out on whether you should add them, you know, use the plus sign, or if they have to be multiplied, you know, because they are happening at the same time, same area. Maybe they actually reinforce each other much more strongly, so they have to be multiplied. Peter Wadhams is still working on that question, and maybe during the summer of 2017 I can present you his answer to my email about that. Okay, we're ahead of a very, very exciting, scary, pick your word, melting season in the Arctic Ocean, and I suggest you pay attention to what's happening there, and it may have very huge consequences for all life on Earth. All right, bye.